Okay, F for felt. Do you know what felt is? Okay, felt is like that soft kind of material. So she's buying sheets of felt and cardstock. So we'll let F be the number of sheets of felt that she's going to buy, C the number of sheets of cardstock. Okay, we did some of this yesterday. First of all, how many sheets is she going to buy? She's going to buy 12 sheets. So before I even look at money, what can I write? Caitlin?
F plus C equals 12.
Very nice. F plus C equals 12.
Good job.
Okay. Now let's look at the cost. So Paige can spend $7.75. What else do we see in there?
It says 50 cents per sheet.
For the felt, right?
Yeah.
And then
75 per.
all right, so give me an equation involving those three things. 0.5 S. Okay, very nice. There's my system. Okay, now, this is one where we talked about yesterday how we have something that just adds up to a total, just the total number of things, and then a price that adds up to a total. So we're doing two totals, but one of them involves how much of it, the other is how much it costs or how much we pay. I'm not going to go through and solve this one, but if I were to, what would you do first?
Are we using elimination?
I would you know what, Abby? You could do either.
Like substitution?
Sure.
I would probably do substitution because.
So you could get F alone and do F is C, 12 minus C?
Yeah.
And then put F down there?
Yeah.
Sure. If you were to use elimination, can somebody tell me what else you could do? What do you think? Go ahead.
I would multiply the top by 0.75.
Okay. So you would eliminate C's and multiply by negative 0.75. You could also multiply by negative 0.5 if you wanted to eliminate F. F. It's kind of hard to say. F. All right. So we've talked about these before. Let's do a break-even problem. So I'm not gonna do the typing service because you probably don't even know what a typing service is because you're too young. Okay. Well, you are, but when I was younger, people would actually type because it had to be done on a typewriter before computers. People's papers and stuff for them. They'd have it handwritten and they'd give it to the typist, and the typist would charge them to type their paper for them. So if they weren't very good at typing, then that's what a typing service was. Crazy, huh? In high school, we even had typing class. All right. So we're going to do this problem so you understand more, because you're so young. Suppose you spend $500 on an oven to bake bread. You're going to start kind of a bakery kind of thing. Okay? You're going to spend $500 on the oven. So this is a break-even problem. So you guys tell me, look above. We have two categories. Is this going to be a cost or a profit to you? This is going to be a cost. Okay, good. And then also, that's a cost, you said. Each loaf of bread costs, well, that's pretty clear then, you 20 cents to bake. So that must mean per, the ingredients and stuff like that. So I'm going to write on the cost side, I'm going to draw a line. Oh, I meant down here. $500 plus what? 0.20. I'll call it X. You can call it L for loaves or B for bread. Okay. Now, I could say C of X equals that if I wanted to. Okay. Then let's look on the other side. We're going to do profits. Profit. profit. What's the profit? Yeah. So, $1 each. So how would I write that? What's the... How would I write that then? How would I write $1 each?
1x.
1x, okay. And if I wanted to, I could write P of x equals 1x. This is really a substitution kind of deal. I want to know when P of x equals C of x. So what I do in here is I just put an equal sign. This is a break even. Even is a equal sign. All right, let's do it. What would you do first? Subtraction? What are you going to subtract? So this is my equation. Subtract what? Mine 0.20x. So what's one thing? 1.00 minus 0.2. 0.8. Alright, so we got 500 equals 0.8x. What are we going to do now? You guys understand you're being recorded right now. So don't act like 2-year-olds, please. Alright. Yes. And what do you get? $6.25. What's $6.25? Good. So after this person makes 625 loaves, at 625, that's when it is equal. But after 625, then that's when it would be making a profit. So that's what that means. Okay, and then the last problem is what I call a mixture problem. A mixture problem is similar to the first one we did above. We have two different kinds of liquid or something, and they form or come together to make a new liquid or quantity. Okay? In this one, we have a chemist. So sometimes you would do this in like chemistry, those who will take chemistry next year or the following year. One solution is 50% acid. So I am going to call the 50% solution X. There's another solution that's 25% acid. I'll call it Y. She combines them together to get 10 liters. Okay, so I have X liters plus Y liters. What does X plus Y have to equal? Very good. So one of my equations is just going to be X liters plus Y liters equals 10 liters. Okay, I have X liters of this kind of solution. I have Y liters of this kind of solution. There's a total of 10 liters. Does that make sense? Okay. Now I don't know if you understand how solutions work. But for instance, let me tell you this. Like, the other day I had a spot on my couch, and you can get it out with rubbing alcohol. You know what rubbing alcohol is? Some of you might use it to clean your ears or whatever. When I went to the store, the solution I bought said 70% isopropyl alcohol. That's what it said. What that means is in that bottle, 70% of it is pure, like the pure rubbing alcohol, and then the other 30% would be water or whatever. So what I'm saying here is in this solution, 50% of it is the acid, and then the other 50% is maybe water. This 25% would be acid, and then the 75% would be water, right? Yeah. Okay. Which one's more diluted then? The second one. All right, good. Let's do the second problem then. So if something is 50% acid, to find out how much acid is in there, I would multiply it by 0.5. Okay? If the second solution is 25% acid, if I wanted to know how much pure acid was actually in there, what would I multiply by? 0.25. The final solution has how much acid in it? 40%. But I know how much there is, right? So I'm going to do 0.4 times 10. So my second equation is for how much acid is in each solution. All right. Let's simplify and